My name is Gates Marshall. My project is about continuous disturbance in upland old growth forests adjacent to Mount St. Helens. It looks specifically at large woody debris as a disturbance event. My fellowship was to join a 45-year project looking at plant community recovery from burial by volcanic ejecta, also known as tephra, in those same forests. So tephra is anything that's ejected from a volcano. So it can be a boulder, it can be a rock this size, or it can be a super fine ash. In these forests, because they are about 14 miles from the actual crater of that pyroclastic blast, and because Mount St. Helens was a lateral blast, that ash, especially the finer ash, is going to travel farther than the heavier, denser stuff, was deposited 14 miles away in these forests. So we spent time adding to a continuous 45-year data set. I then took that data set and tried to expand the inference space of the original project to look at more general responses to disturbance. Mount St. Helens has erupted and buried plant communities 3 times that we know of so far, 1980, 1800, and then in the 1400s. So those are intermittent catastrophic disturbances. Disturbances like that shape the type of plant communities that are in that area. However, I wanted to look at something less intermittent that could be providing selection pressure that would determine what those communities are composed of. So a big part of my finding was that in the understory of these old growth forests, the plant community composition was massively clonal as opposed to non-clonal plants. So when we're talking about clonal plants, we're talking about plants that have more than just seed setting or sexual reproduction as a life history strategy. They have the ability to generate genetically identical clones. It's widely seen that clonality enables plants not only to just resource share and seek more beneficial habitat, but it also allows the plant community to recover from disturbance. So if you have a primary plant that gets buried by woody debris, it can send out a clone next to it that has access to the original resources that the first plant did. But of the community that has recovered since the Mount St. Helens eruption, 89% of that plant community is clonal. And so overall, my project was looking at the whole plant community subset into clonal and non-clonal plants. These are the non-clonal plants, these are the clonal plants, and then looking at their response to changes in woody debris. And it was 16 species, and 14 of the 16 species showed no significant negative response to burial by woody debris. To me, that points to like what would be further research, which is looking at continuous woody burial as the selection pressure that created a plant community that could recover from burial by ash deposit, because it's been continuously recovering from burial by woody debris. One of the coolest things I've learned is that you can participate in other people's research and be really excited about it and be forming your own question the entire time. And you don't need to form a novel experiment. You do not need to carry out a brand new regime of field work. You just need to be continuously observing and forming a thesis while you're doing that work. I worked with Dylan Fisher and Maddie Dela Cruz. We worked All summer we actually worked on 3 different projects associated with Mount St. Helens tephra, and in really different scenarios. And then we kind of each chose different aspects of that to do analysis on.